What's up, everybody? Welcome to our podcast. Today, we have the honor of hosting Grady Booch, a true pioneer in the field of software engineering. Grady is renowned for his work in object-oriented design and as one of the original authors of Unified Modeling Language, UML. As an IBM fellow, he had made groundbreaking contribution to software architecture and has continuously shaped the way we think about developing robust and scalable systems. We are thrilled to have him here to share his insights and experience with us. This is for public, and who is Grady Booch for me? Grady Booch is a role model for me, is a teacher, is a software hero. Whatever I have learned so far, I have learned with the aim of becoming a Grady Booch, a Kent Beck, or a Bertram Meyer. In a time when ugliness, injustice, and lies have infiltrated the IT field, as in all areas, being Grady Booch means being the truth for me. To be Grady Booch is to aim for the future of software to be more ethical, sustainable, and intellectual. So, welcome, Grady. It is my pleasure to have you today.
Thank you for having me. And I should say aloha because I'm coming to you from the islands of Maui, Hawaii. Thanks for having me.
Thank you very much. It is our pleasure. So, today we have a lot of interesting questions regarding to AI, regarding to software architecture, and of course, object-oriented design. So I want to start from the first question. So what did it cost you to become Grady Booch?
Well, that was an interesting question because I don't know how to be anything else other than Grady Booch. And so I don't think you can attach a cost to it. It is who I am. I am comfortable with the decisions I've made in my life. I've honestly lived a life with no regrets. And so it has cost me nothing, but it has given me so much joy and value and beauty.
Great answer. Great answer. So we know that Grady had a lot of interesting, valuable books regarding to UML, regarding to object-oriented software design, architecture. So why did Grady Booch stop writing books?
Well, actually, I haven't stopped writing. At the moment, I'm working on 2 books. There certainly has been a pause in my writing. And I think it's because after the work I did in software architecture and software engineering with UML, I've been busy working with people building real systems. I've been busy doing a lot of research in the AI space. Currently, I am assigned to our AI laboratory in Cambridge at MIT, where I'm basically trying to provide some architectural assistance to the work that's going on with our large language models. The last 6 years, I have been working with a set of neuroscientists to better understand the architecture of the organic mind so that we might be able to better express new kinds of architectures for future AIs. And then prior to that, I've been doing some really fascinating work in conjunction with NASA and some IBMers on basically trying to build a HAL for a mission to Mars. Indeed, if you look in my video, you'll see a panel from HAL overlooking my left shoulder here. You may know of the story of the Sword of Damocles. This is my Sword of Damocles hanging over me, and it reminds me every day. Any rate, I am writing 2 books currently. The first book is a book on software architecture. I've been trying to get this out for the last literal decade, and it's been a difficult one because I have in my bookshelves over here probably 50 or so books on software architecture. And while I find many of them interesting, I find most of them to be focused on the very narrow problem of web-centric systems of global architectural scale, which is interesting and it's important, but it's not the only kind of architecture out there. And while there's a tremendous amount of work going on in that space, the world of computing is far grander And so I'm trying to basically capture in this book what I have learned over my 40 plus years in the space, plus documenting the architecture of a number of systems that people probably don't know the architecture of. The architecture of Photoshop, the architecture of AlphaFold, the architecture of uh, our I'll give you an example of weather systems, meteorological systems. So it's these kinds of things that there are chapters in which I'm describing the architectures of them, where, of course, architecture represents significant design decisions. And in the web-centric space, there are a certain set of decisions, but in other domains, there are many other kinds of decisions. And so I'm trying to write a book that expresses what is the process of being an architect across these domains. The other book I'm writing is, let me tell you a story. A few years ago, well, actually a decade ago, I was on the board of trustees for the Computer History Museum. And at the time, we just hired a new CEO, John Haller. John had come from PBS in Europe. And so I asked him one day, hey, John, why don't you do a documentary like Carl Sagan's Cosmos? He paused and said, Grady, why don't you be our Carl? I paused and said, I'm no Sagan, but that's an intriguing idea. So for the last dozen or so years, I've been working on a documentary that has a book, but also we have in mind 12 one-hour episodes that presents the intersection of computing and what it means to be human. And so it's a book and a series that's directed to the general public, not to the technical world. So as all the other books I've written about have been for a technical audience, this one is meant for the general public. So those are the ones I've been working on. I certainly haven't stopped writing books, but I'm writing 2 very difficult books, and I'm enjoying the process.
Yeah, definitely. That's really great to hear. So when should we wait for these books? The
I hope to
publishing.
finish it before I die. So that's all I can tell you. My editors have been most patient and long-suffering, and I think they recognize that this is a book that there's a story inside me screaming to come out, and it will come out when it is ready. Such is the nature of writing.
Yeah, exactly. So, Grady, what is your purpose? What do you want to change? Why you are trying to do all this stuff? What's your main purpose?
I have been so blessed by the computing industry. It has enabled me to be living here in Maui. It has taught me so much. I have met thousands of incredible people, and hopefully I have been able to change the way people develop software for the good in some ways. I think I've done that. But I also know that there is a gulf between what we do inside our world and what the general public observes. To many, it looks like magic. To many, it looks like it's inconceivable to understand computing itself. And yet we know that the fruits of computing have considerable impact upon our individual lives, upon our society, upon our nations. And so to that end, I think I'm in a unique position to describe as an insider how I have seen computing evolve and how I think it will evolve and the forces that will shape it, and do so in a way that I think the general public can understand. An informed public is better able to make decisions about the technology that will impact them. And we are not in a place, we shouldn't be in a place where the techno bros are the ones who are driving our future.
Definitely. So, do you think your, let's say, dreams are reachable in the context of modern software IT industry?
I am confident in the ability of the human spirit to adapt and change. I know even in the presence of the technologies that are just earth-shatteringly changing everything we do in ways that I think are different than what the Elon Musks and Sams and Gregs and others believe. They have a particularly narrow, I think, view and not very human view of it. And so in that sense, I think that like all technologies, there is an opportunity for computing and AI in particular to amplify what is the best in us, but it also has the ability to diminish us. So, yes, I am hopeful, and I hope I can contribute through the writings I'm doing now. I hope I can contribute to the dialogue that pushes us more toward the good as opposed to the bad.
Exactly. I hope so. I hope so. So let's go back and talk about Booch Method
Yep.
and 70s, 80s. The software development focused on building algorithms rather than object-oriented thinking. So what was your role and how you did come to create the Booch Method?
Well, in order to answer that, I think it's worthy of describing that we are in a similar point of inflection in computing at the moment. And when I developed the Booch method, there was an important inflection. We were moving from what I call the first to the second golden age of software engineering. We're really sort of, I think, in the tail end of that second golden age, and probably at the cusp of a third golden age, because the nature of software engineering is changing in some subtle and irreversible ways. So back to the time in which I did my work. So I went to the Air Force Academy, and I chose to go there because I wanted to do two things. I was deeply interested in the space program, and in the 70s, there was no commercial space program. If you wanted to get into it, you were probably going through the military. And the second was computing. And the Air Force Academy was one of the few places in the world that brought those two together. I could have gone to any number of universities, but those two things came together in that place. I graduated with a degree in computer science, and then I was immediately assigned to Space Command at Vandenberg Air Force Base, which here I was a 20-something, and I was being made a project engineer for projects in support of the military space shuttle and military space program. That's pretty heady, cool stuff. And it was a great place to be. We'd have a launch like once or so a week almost, and it was this exciting and vibrant place to be. But there's one interesting thing, well, many interesting things, one of which is that in that era, most of the really complex systems that were on the bleeding edge were not commercial systems. Needless to say, in the business sector, there were certainly lots of complex systems, but the ones that were pushing the edge were mostly in the federal and defense sector. We were building a distributed real-time system involving 32 mini computers, fusing data from 400 different satellite sensors. And that's a hard problem. And here we were doing with technology from the 70s. And so architecturally, it was very, very challenging. The languages that were dominant at the time were those that were supporting algorithmic decomposition, Fortran, COBOL, and the like. C was out on the scene or just barely around the time. But it was clear that there was a crisis in software development. Indeed, there was a NATO conference in the late 50s on that very one due to the work that was taking place in SAGE, the semi-automatic ground environment, a major military effort that was a huge command and control system. It was several $billion in its cost. It probably consumed about 30% of the software developers in the United States when it came about. So the Department of Defense decided, look, we've got a challenge here. We've got several thousand languages we're doing. Why don't we create a new language? And this language was Ada. So at the tail end of my tour at Vandenberg, I was asked by one of my former instructors at the Air Force Academy to come back and teach at the Academy, which was amazing. I was back at the Academy within 3 years. I think I'm the youngest professor they've ever had. And the role they put me on was to help the Department of Defense apply modern software engineering techniques to this new language. And that was the task I was given. So I taught a bit, but I did a lot of travel working with and understanding what was then the emerging new software engineering ideas from Barbara Liskov, from Gauguin, from David Parnas and the like. And that's what led me to realize that there are some fundamentally different ways to design. Object-oriented programming was a thing, as we saw in the language of Simula and what was going on. But I was looking at it at a higher level of abstraction, and that was object-oriented design. And so my work led me to fuse those ideas to provide a framework in which Ada could be used. There was a chance encounter I had with this really fascinating developer. He was in my audience. He asked me some really good questions. I went up to him afterwards and we hit it off. And we also found out that we had both written a paper for an ACM journal. It was published at the same time. Mine was on the Booch Method. His was on this little language called C with classes, which became C++. It was Bjarne's Strustrip. And we found our work amplified one another. So Bjarne and I hit it off. We went on a lecture series around the United States. And if you look in his first edition books and mine, you'll see that we reference each other quite a bit. So it was very clear that the work I was doing was applicable not just to the world of Ada, but to the coming commercial world. And so that's where the Booch method came from. It was a way to look at building complex systems that were different than algorithmic decomposition, but they were based upon algorithms or based upon decomposition according to classes. Now, in that time, I think we overemphasized the importance of inheritance. But what we did do right was the notion of looking at it from bringing together data and operations in one place, and that's the Booch method.
That's great. What do you think about the Booch method in the modern era? I mean, does the Booch method still retain its significance in hybrid paradigms of the modern era?
Well, the great thing about good technologies, I believe, is if they are really effective, then they become part of the atmosphere. Every framework we use today has an object orientation to it. Everything does, because you just don't see just pure algorithmic kinds of things. They tend to be wrapped up in objects. Again, little inheritance, there's some of it there, but every framework is this. So I think in many ways, the stuff we did on object-oriented programming and object-oriented design has endured and has become just part of the atmosphere in which we swim. So I think I'm very pleased with that. The particular approaches for how one does it, they've been subsumed into agile methods, and we'll talk about that a bit more as the podcast progresses, because that's part of the evolution of the work I've done. The UML notation, it maybe at its peak got 20, maybe 25% of the marketplace in terms of developers using it, and that's not a small amount by any means. Do people use it today? Sure, they still do. Not as much, certainly. The James Webb Space Telescope, the developers use the UML on it. We see it still in lots of interesting places. And we see the reinvention of it in different ways, such as what Amazon has done with their particular architectural notation. It's not the UML, but it's the same kinds of ideas. Microsoft did the same kind of thing. So the principles have endured, and for that, I'm very grateful. But the ideas, they're pretty fundamental. And the idea of object-oriented versus algorithmic decomposition versus functional decomposition, it still stands. In fact, let me talk about functional decomposition, because I know that was on a list of things for us to talk about.
Yeah, exactly.
Part of my work with the Computer History Museum, I conducted a number of oral histories of famous computer scientists. I interviewed Linus. I interviewed Fred Brooks. Spent a whole afternoon with him and his wife and his grandchildren in London once, or outside of London. And I also spent time with John Backus. So another story for you here. When I was 12, 13, I wanted to write programs. So here I was in Amarillo, Texas. I knocked on the door of every company that had a computer back at that time. Of course, you're not going to hire a 12, 13-year-old. But I knocked on the offices of the IBM building, and a salesman took me in and said, "Hey, this is interesting stuff. Hey, kid, here's a Fortran manual. Go read it." And I expected he'd never imagine I'd come back. But there I was the next week, and I'd written a program. Your typical Hello World program. Well, it wasn't really. I had written a small program that calculated the energy release of two particles approaching one another at near sublight speeds and seeing what it would do. So that was my first program I ever wrote. I still have the cards for it. And so that's how I learned. I sort of self-taught myself Fortran. Well, jump forward here, and I was asked to do an oral history of John Backus. I took that manual with me, and I had John sign it. I still have it to this day. John sadly passed away maybe a couple of months after I gave the interview. His wife had passed away a few months before. I think, honestly, he died of a broken heart. He was so
Oh,
deeply in love with his wife. But I asked the question to John, hey, John, what about functional methods? Because John had really basically invented them. That's one of the things he did after Fortran. And he said, well, the thing is, Grady, that, that functional programming languages allow you to do hard things easily, but it's almost impossible to do easy things. And
no.
so I think there is value in functional programming, but it's a relatively narrow domain. There are certain kinds of stateless architectures you'll find in web-centric client-server systems where functional approaches make a whole lot of sense. But that tends to be a small piece in the spaces between systems, between the client and the server.
Mhm.
It's a great way of looking at it, but will it ever, dominate? No, it's a small piece, not unlike what formal methods are. They serve an important role, but they're not general enough to be useful.
No,
So there's nothing wrong
great.
with it. It's just that it's suitable for certain things, but not suitable for everything.
Okay, so do you think we can design a huge application using only functional basic decomposition, or we should use object-oriented and functional together like hybrid mode?
My experience in working with systems of a variety of different kinds of complexity is that there always end up being hybrid. That I have seen some modest sized systems that are completely functional orientation. That's fine. They're very difficult to maintain in general, was what I've discovered. But virtually every system that one builds these days, they're a multi-paradigm in nature, and that's okay. That's just the
No.
nature of complex systems.
Okay, so but what do you think about having a hybrid mode in one programming language? Does it make the language complex to learn because you have object-oriented mind, you have functional mind? So how to deal with this problem?
Yeah, there are very few complex systems that are of a single language. Ada
Mm.
was an attempt to build one language to rule them all. And it never succeeded because there are still some things that are hard to do in Ada. My language of choice these days is Python. I primarily use that
No.
because it allows me to access a whole bunch of libraries that are useful for the work I do in AI. But even so, I'm mixing Python and C++ in many cases because that's just where the pieces live. So I think it's good as a developer to know multiple languages.
Yeah,
Now,
exactly.
languages like React and Haskell and Scala, there are always these fad languages, and that's wonderful and great. And I think there's a role for all of those. But it's much like being multilingual in human languages. If you are able to master one language, and it's easier to master others as well.
Exactly. But from the language perspective, what is your favorite one from the back to now? For example, maybe Smalltalk, Fortran,
Smalltalk's my
COBOL.
absolute favorite language. And it's not so much because of the language itself, but for the whole environment. In fact, the very first prototype I built of what became ROSE, the Rational Object-Oriented Software Engineering Tools, I did in Smalltalk. I had the wonderful opportunity to work with Adele Goldberg, who is one of the inventors of Smalltalk, along with
Yeah,
Alan
great.
Kay. And I learned so much from her. And I loved Smalltalk because it was intellectually perhaps the most fascinating and self-consistent language I've ever encountered. If you ever have a chance, go study its meta model architecture. And it is absolutely beautiful. It's where there are these, in Hofstadter terms, there are these strange loops that exist among the classes themselves. On top of it, you had an incredibly rich library in which you could work with Smalltalk. And then finally, the development environment for it was such that you could poke into a running system and observe in a running system, which was Fantastic. In many ways, modern IDEs are still trying to catch up with what the Smalltalk IDE did. It was perfect. To use a line from Mary Poppins, it's positively perfect in every way.
Oh, great. So, but I realized that most of the golden age engineers really love Smalltalk, like
Yeah.
you, maybe other guys. But what was the real reason of letting Smalltalk die?
Well, it seems like everything that came from Xerox PARC tended to die. So Xerox PARC never really understood how to take a great technology like that and on its own bring it to fruition. Of course, Jobs, learned so much from what Xerox had done, and we found that in the Apple Lisa and what became the Macintosh. Uh, there was at the time in the computing industry a wonderful primordial soup of ideas. If it weren't for Tim Berners-Lee, and if the good folks at Apple had made one small change, then HyperCard would have been the basis for the modern web. HyperCard was a beautiful system. It has the notion of meta links. Indeed, around that time when Tim was working on the web, there was a lot of activity about meta links and the like. And what they made the mistake of in HyperCard was linking between card decks, if you will. And so that was a mistake. But of course, is what Tim allowed across machines themselves. But I think it points out that in every inflection point, there tends to be this swarming set of ideas out there. And eventually one pops loose and it becomes the right one. Smalltalk was not one of them, but it influenced a lot of us. Like Kent, for example, he and I were both deeply influenced by Smalltalk.
No, that's great to hear. That's great to hear. So, let's switch to the paradigms. And you are actively worked on object orientation, object-oriented programming. So, my question is, what went wrong with the legacy of object-oriented programming? Because nowadays people think that, okay, you have encapsulation, information hiding, inheritance, polymorphism, that's all. That was object orientation. What do you think about it? Why modern software development books talk a little about it and mostly focuses on keywords of programming language?
Yeah, well, I think many of the modern software engineering books focus upon just the language itself and not the methodology. That's just a fundamental problem itself. But I think it's again because the ideas of abstraction, information hiding, separation of concerns, these are, again, part of the atmosphere. And I think there are a lot of really bad software engineering books that don't talk about that. They don't help you think in that regard. But because we have so many frameworks at our disposal, uh, it's like, gosh, I need to do messaging. Well, gosh, I'll choose Kafka. And all of a sudden, many of the decisions are made for you. You don't have to do those abstractions because the abstractions are there for you already. The work that's been done in domain-driven design, for example, does, I think, a good job of bringing us back to the ideas of abstraction, because here that community is emphasizing the importance of building these closures of abstraction. But for the most part, if you've got somebody who wants to build an app or something, they're not thinking about it because they don't have to think about it. Because again, they choose a framework. I'm going to choose a particular application framework and a client framework. They just have to throw in a little bit of special sauce for what they're doing, a little bit of abstraction, but they rarely have to build abstractions of their own. So that's why I don't think anything went wrong. It's just that it became so subsumed and so part of the fabric in which people write code that very few people have to write their own abstractions. I think the similar phenomenon is happening in the AI world, where there are very few people who are going to write their own large language models, but a lot of people are going to use those. And so they're going to be building upon things for which there is a very deep intellectual basis. And so it is in object-oriented programming now. There's a deep intellectual connection to all these frameworks that uses abstraction, information hiding, and the like. And so it's there already. Hasn't failed. We just don't talk about it much anymore. Now that's a danger, because if people want to do the same things over and over again, I'm going to build another little app for my iOS device. Fine. There are tens of thousands, hundreds of thousands of those. We sort of know how to build those. And so if you want to do something radically different, that's where it takes some of the out of the box thinking. And that's why I look at people who are still understanding those fundamentals, because they're the ones who are going to build those really interesting new systems.
Mm. Definitely. But how about the object orientation in modern languages? Why are most modern languages not truly object oriented, even though they claim to be? Is it a marketing, or what are you saying about
Yeah,
it?
there's a lot of marketing issues. I think it's like the word organic, that it has little meaning these days anymore. But if you have a language that supports the creation of new classes, it's an object-oriented language. It may not have inheritance. I think, again, we oversold the importance of inheritance, and that's okay, just as long as you're combining data and operations in one place and your language supports it. You've got an object-oriented programming language.
Yeah. Okay. So let's talk about software engineering. Why it is nearly not possible raising new Grady Boochs. So what went wrong with the overall software engineering?
I don't think anything went wrong with it, so to speak. So I reject the premise of the question. Software engineering has changed because
Okay.
ultimately it is, well, first off, calling it engineering is a bit of a misnomer, because we're not a licensed activity. But it's engineering in the sense that it is an activity that involves the resolution of forces upon a system. And in software engineering, we have the usual cost schedule, uh, resources kind of thing. There are legal issues, there are ethical issues, there are issues of compatibility, there are issues of all the goodnesses of resilience and maintainability and all those kinds of abilities. So all of these things come together. And as a software developer or software engineer, my role and the role of the team is to build a reasonably optimal system that balances all those forces upon the system. That's the nature of software engineering.
Mm.
And if we combine that with modern agile approaches, again, because I think we as interesting have such a richness of libraries around us, it's not difficult to say, let's get together a group of small people, a small group of people, bright people, and go build something. It doesn't require a lot of process discipline to do it, especially if I'm building something that is disposable. I build an app that, hey, if I'm not successful, I'll just get another round of funding. If I'm not successful, nobody's going to die. So there's this spectrum I find, sort of this space, this latent space of three axes. And let me describe it to you, and I'll tell you where I think modern software engineering is. So this is sort of the mental model of complexity. On one axis, let's say it's the x-axis. This is one of ceremony. So if I'm working with a venture capital firm, I'm a startup. I'm just going to hire some great people, and if I fail, then hey, nobody dies. On the other hand, if I have a system and I'm using lots of other people's money, like taxpayers, I'm building the next generation, missile guidance system to replace our nuclear arsenal. You're going to have much more accountability. So there's higher ceremony. That's the x-axis, higher ceremony, and where you are on the axis will impact your approach to development. The next axis is one of risk. If I build something, it's the next generation Tinder. Oh gosh, I missed a connection. Too bad. On the other hand, I can build applications in which, oh, if I fail, somebody's going to die. Well, again, we have a spectrum along the y-axis, and that changes how I approach the system. The third axis, the z-axis coming into us, is one of complexity. If I'm building yet another app that reaches out to a database, presents it to me in a certain way, my gosh, there are hundreds of thousands of those kinds of things. We know how to build those. And in fact, in the literature, most of the software architecture books that I find these days are just that. How do I build those kinds of things over and over again? There's value in it, no doubt, because we're going to have several 100,000 more of those. But on the other hand, if I'm building something fundamentally novel, like an AlphaFold, or dare I say, use the word trying to build an AGI, or building some global system that I've got to be, totally resilient and all that, then the complexity is such that you can't fall back upon just those kinds of things. So in this latent space, there's a lot of software engineering that takes place where you don't need a lot of discipline because it's kind of close to the origin. And that's fine. There's a lot of software development that goes on there. If we can teach people how to think and program, that's enough to build good things. But as I start moving further out from the origin, that's what the discipline of software engineering and its importance, I think, increases as you move outward.
Yeah.
So software engineering nothing gone wrong. I think it's just that we've actually been exquisitely successful in engineering systems. And that's a good thing.
Yeah, that's great to hear. So, Grady, what do you think about modern software architecture practices?
Well, again, I think that one of the signs of the maturation of software architecture is we as an industry have understood the basic architectural styles that exist. In 20, 30 years ago, we didn't fully understand all of them. But I think it's easy to enumerate a couple of dozen different architectural styles that virtually every modern system looks like these days. Let's take, for example, ChatGPT and all the things that surround it, and agentic systems that are emerging. Many of them are turning into what I call a pipeline architecture, where you take a basic system, you throw some agents at it, you have those agents interact with one another in various ways, and you then rank the results at the end. And maybe along the way, you do some clever things with regards to agents that might look at various tree structures, symbolic structures, and then prune the search space around that. That's a pipeline architecture. We sort of know how to build those. So it's a sign of the maturation of the AI world that they're beginning to rediscover these kinds of architectures. So if anything, I think that in the world of software architecture, we made it easier because we have codified so many software architecture decisions in frameworks, and the idea of architecture as a set of design practices or design decisions, I think is again part of the atmosphere in which we live. If I've got a simple system close to that origin, then frankly, I don't need a lot of discipline to come up with that architecture. But as I move further out, then it requires a little bit more intentionality.
Yeah, exactly. But are you happy with modern software architecture practices? Do you think that, yeah, that's completely 100% okay? That was the right thing.
Yeah, I mean, again, there are so many web-centric systems of global scale. We sort of know how to build those. There's not a lot of, the hard problems have been solved with regards to scalability and observability, and they've been codified in many of the AWS kinds of things. So the things that we thought were hard a decade or so ago are no longer as hard. And so in that sense, architecture itself has become part of the atmosphere in which we live. I think the next challenge is actually at the interface of symbolic systems and AI systems, where those two meet together. We know that there are severe limitations to what transformer-based architectures can do. We know that there are severe limitations to what symbolic architectures can do. And so the interesting challenge right now is, how does one bring those two things together? This is why you're seeing activities around agentic systems, which are on the cusp of those. What AlphaFold did is a good example of a neurosymbolic system, because they brought in typical neural systems, but also classical Bayesian methods as well. And there's a lot of experimentation going on in that space, which is healthy and wonderful and good. But I think for certain classes of AI systems, actually I should say AI symbolic systems, in the next decade, we'll learn what those architectural patterns are. And that's great. That's wonderful. It indicates to me a growing maturation of our field. And it also indicates to me that we're not done yet. There's still so many exciting things to discover and explore.
Okay. So, as you mentioned, we solved a lot of problems. How about the solving way of the problems? Are you happy with that? We solved it, but we solved it in this way. Most
Well,
architectural problems.
as an engineer, I make the observation that if it works, it is useful. And again, it's back to an engine. It's back to the balancing problem. Um, if I'm building something that's useful, that's great. And if I can get a good return on investment on it, it's even better. And then if I can get a lifetime of a good return on investment, it's the best of all. There's a lot of software being built for which the return on investment is highly suspect. And I'll point fingers at Sam and Greg at OpenAI because consider, no doubt, ChatGPT and all the things that surrounded it have been extraordinarily useful. And they have a very interesting architecture. But they have spent literally billions of dollars upon what they've done. And it's not yet clear if there is a similar amount or even 10 times that amount, which is what you try to get in an ROI, of value that those are replacing. It's interesting. There's utility, but there's no evidence that yet suggests that the ROI of these systems is yet sustainable. And so that's why, hey, it's fun to build these things. It's great. But I like to work with systems that are enduring in their value, ones that are multi-generational in their nature. And many AI systems, I'll stop and say virtually all AI systems of what we see in the modern age, they have yet to prove themselves in that regard.
Yeah, yeah, yeah. Talking about AI, what do you think about the reality behind AI? Because I got a lot of questions regarding to the AI replacing software engineers. So, is it true? I know your ideas, but let's share it with our audience.
Sure. I believe that artificial intelligence will change the nature of programming in the same way that the advent of compilers did, which was basically shifting things to a different level of abstraction. So Copilot and others, they are easier than reaching out to Stack Overflow. They're convenient, but they're also extraordinarily limited in terms of the domains in which they're useful. Again, if I'm building another one of these 100,000 client apps that are on the web that are dealing with a small database, yada, yada, then hey, yeah, the Copilot and things will help me because they make it easier for me to understand APIs and the like because API documentation is so bad. So in that sense, it helps, it accelerates. I find that it helps bad programmers write code much more quickly than they could in the past. It is of marginal use, I find, to really good programmers because it doesn't change the way they work. And it's only a modest inconvenience to them because it saves them from Googling something. In fact, Google search has become so bad. Copilot and the like are useful because it's better than Google search these days. So yes, it has a role. It helps us in moving up a level of abstraction. Will it fundamentally replace us? No, because no modern transformer-based architecture for an artificial intelligence can reason or understand. It's still something that requires a human.
Okay, but how about providing the proper commands like prompt engineering? I can provide the exact description of my business, and I think ChatGPT can handle the task for me. Does it mean that the era of engineers are coming to end?
Well, what do I call a language that has sufficient expressiveness and precision that allows me to build an executable artifact? We call it a programming language. So prompting becomes yet another programming language. And in its simplest form, prompting allows me to build the same simple things over and over again, which is great. But the moment I start trying to maintain it or tweak it, saying, "Oh, I'd like to do this, but if this little text input were moved up a little ways or slid to the side or change the color or have a tip bar to it," all of a sudden you have a level of detail that exceeds anything you can do in the prompting. Prompting allows you to build throwaway prototypes more easily, but it's not going to get you to an industrial strength system that people can get a good ROI on. It's great for demos, great for throwaway things, but I have yet to see it useful for anything else.
Yeah, great for
Nor do I
prototype.
believe it will ever be useful for anything beyond
Oh,
that, just because of
yeah,
the limits of the expressiveness and precision of them.
yeah, that's nice to hear. So let's switch to the internals of software architecture. So I want to hear your honest thoughts about clean architecture, about domain-driven design. Let's start from the clean architecture. What do you think
Well,
about
I
it?
like the ideas of domain-driven design. I've spoken to some of the authors behind it. I think they're doing good stuff. I think they're providing good value. I think it's a great way of approaching a system. Event-driven architectures as well too. I think there's work there to be done that's very, very useful. In each of those cases, I think both of these approaches are trying to return people to the activity of intentional architecture, intentional abstraction, and that's a great thing.
Yeah, behind the
So yeah,
domain-driven
good
design,
stuff.
yeah, works. Yeah, behind domain-driven design, we have like responsibility driven design idea. So
Yeah.
what was before domain driven design? I mean, we started to talk about domain driven design around 20 years ago. So
Yes.
how was the situation in object oriented design before domain driven design? Because domain driven design said that, okay, you have domain models, they are business centric models. You should encapsulate the business inside your classes. But before that, I think maybe we used object oriented programming in a wrong manner.
No, I
Or
think we did the same kind of thing. I think domain driven design, it's wonderful. It's a great packaging of ideas, but the roots of its ideas are no different that we talked about 20, 30 years ago. The phrase I used in the early Booch methods was you would capture the vocabulary of the problem space. That's domain design.
yeah,
Those are the
exactly.
exact words we use. And so domain driven design packages it up, I think, in a very approachable and useful way. But the ideas are not new in that regard.
Yeah,
So I
definitely. Like,
celebrate what the authors of domain driven design have done. They put together a very approachable idea. But again, the roots of the idea are are not fundamentally different than what went
yeah.
on a few decades ago. The same is
Mhm.
also true of event-driven design. That if you look at events, it's a way that, in fact, this is why sequence diagrams were created in the Booch method and the UML, because they're a way of looking at the flow of activities through a system via events.
Exactly. Yeah. Talking about UML, I realize that people are not actively using UML nowadays, especially. I work with different companies around the world, and
Yep,
approximately I have never seen UML because we have just simple user stories. Okay, let's try to
yep.
implement it. Yeah, so what went wrong with UML? Why have people stopped actively using it, especially in modern days?
Yep. Well, see, people still use whiteboards where they use boxes and lines. I'm sure you see that in all of your places.
Yeah,
What the
definitely a
UML
lot.
attempted to do is to provide a little bit more formality to that. And I walked away from the UML after the 1.0 standard. I was emotionally exhausted from the process. Uh, Jim continued on with it. And I think the object management group made a fundamental mistake that broke the UML. And that is there
All
was
right.
a small faction of folks who wanted to turn the UML into a programming language. And in order to do that, it required much greater precision. I've always viewed the UML as something that was meant to reason about a system under design. And so its semantics were intentionally vague in some places. Whereas if you're turning it into a programming language, you can't be vague. So I think that's ultimately what killed it. But again, the ideas, they sort of been reborn in Amazon's architecture notation and Microsoft's architecture notation. Both of those, you may have heard of Philippe Crucian's 4+1 model view. Amazon's approach and Microsoft's approach are pretty much the two physical sides of it, the implementation architecture and the deployment architecture. And we had particular notations for that in UML, and whereas Amazon and Microsoft aren't using those icons, same semantics. So in that sense,
Yeah,
it lives on, but in a different way.
Got
And
it.
so for that, I'm grateful. I still use
Yeah.
the UML, by the way.
You should use.
Yes.
So, yeah, definitely. That's great to hear. So, how about let's dive into details of like from high level design to internal design. I just want to hear your honest thoughts about modern language being object oriented, like C Sharp, Java. Do you think that these languages are truly object oriented? I asked this question to Matt Storgerson, by the way. So
Yes.
I want to
Too
hear you.
object oriented.
Yeah.
Gosh, I don't know, because I'm not experienced in C sharp, so I don't have a good
Okay.
answer to that one. I can't give you an informed one. I know that heck, I can do object orientation in COBOL or C. I can also do it very badly in a pure object oriented language. So the growth of languages has been an interesting one. I've dabbled a little in Rust and Haskell and Scala and the like, and I'm fascinated by the continuing development of new languages. And I think there's always room for these niche kind of languages. Frankly, I'm comfortable with Python. So, I guess I'm evading your question because I don't have any good answer for you because I'm really not that experienced in those kinds of languages. I'm comfortable
Yeah,
with the
that
languages
that's
in which I'm
something
working
okay.
these days. And even
That's
Python,
something.
it's a multi-domain language. You can use it in a functional way.
Yeah, definitely. But can you implement the exact object-oriented thoughts using Python?
Oh, absolutely. I do all the time. Now, Python, of course, is not a type safe language, but I can achieve some of those kinds of approaches through certain idioms. But when I'm making my design decisions, I'm always thinking in terms of abstractions, no matter what language I'm doing. And you'll see that
Uh,
reflected in the code of any language in which I write.
yeah, exactly. I have questions related to abstraction encapsulation. So, regarding to object-oriented design, what are the common mistakes you see developers make in object-oriented design?
Um, Over abstracting is a very common one. That happens a lot. Um,
Definitely.
so that's probably the biggest one, I would say, the most common problem that people have. They'll
What do
over
you think
abstract.
about dependency injection? Because we are moving all the dependencies outside. Now we in our class we have 8, 9, 10 dependencies. We are maybe breaking encapsulation somewhere. We are actively they started propagating dependence injection as a good design pattern, and we think that okay, now if you have dependence injection, you have one of the parents, best parents.
Yeah.
So let's focus on implementing everything, moving everything, every dependency to the outside. But I heard that many of really good engineers still are not using dependence injection as we think in this way.
I have no great comment on that one, other than to say that simple is always better.
Yeah,
And
definitely.
if you've got those kinds of dependencies, then you're probably doing something wrong with your abstractions in the first place.
Exactly. Yeah. And this was what I was expecting to get. Yeah. So let's talk about the internals of object orientation. If I design one language and I say that it is object oriented, what are the foundations should live in this language? So, what are the foundations of object oriented design?
I think the notion of being able to combine data with operations the ability to have information hiding, the ability to encapsulate those things, the ability to have a separation of concerns. You have that, and you've got an object orientation.
Great. Now let's talk about a bit internal. So, what is the definition of encapsulation according to Grady Booch?
Encapsulation is the drawing of a line around an abstraction that says everything inside that line is part of my abstraction. Everything outside that line is the outside view of it.
No.
It's providing encapsulation defines a boundary of an abstraction.
Exactly. Yeah, that's great answer. So, how about abstraction? I mean, the somewhere encapsulation and abstraction flows like match. So, where encapsulation ends, where abstraction starts.
There is a dance between the two, because as I consider how I use an abstraction, it will require me to reconsider where the boundaries of that abstraction are, and not just the boundaries, but also the entry points. What do I make visible outside the boundary versus what do I keep inside of it? And so this is the life of a vibrant abstraction. You rarely get an abstraction right the first time, because you'll always miss the encapsulation and the information hiding, and you'll get the abstraction at the wrong level of detail. And so as one continues to evolve a system, and your abstractions and the boundaries around them will change until they'll eventually stabilize. They may not be the perfect one, but they're a reasonably optimal one based upon the forces that shaped you in that first place.
Great answer. I loved it. So, I think that's all. Thank you very much, Mr. Booch. It was my pleasure to host you. As I mentioned, you are one of my role models, and I really love your books. I really love your publications, and I will definitely get your books as soon as they published. So thank you very much for
And I have to
participating.
commend you as well, because I've been interviewed by many folks and you ask some very good questions. So thank you for that.
Thank you very much. My pleasure. So again, thank you very much. Have a nice day. And I
I shall.
hope in the future we'll have a second session for our podcast. I really hope.
It will be within the realm of possibility. Yes.
Thank you very much.
Aloha.
So,
Thank you for having me. Bye
thank you
now.
very much. Bye. Bye.